Welcome back, everyone. In this video, we're going to take a look at profiling and optimization. Because there is a lot of typing in this one and a lot of commenting, I decided to just have it all be in front of us and review the material instead of typing it as I normally do, in the interest of keeping the video to a reasonable length. But Python does allow you to profile your code and optimize it, give you ideas to or help to optimize it. Let's take a look at some of the things that I've written over here. They're here to determine which parts of the code absorb the most execution time, and so you can optimize them. When should you optimize? First, do we need to optimize? If speed is not a problem, then there's really no need to optimize if the code is doing what it's supposed to. If yes, then we need to know which parts of the code should be optimized. We can use a profiler such as cprofile, which is built into Python, which we are going to be using today. Usually most of the execution time occurs in a small part of the code. If you optimize that code and leave the rest alone, you should be doing well. Now I have a list over here of movies, which I pretty much just copied and pasted a bunch of movies that I found online, and I just copied and pasted these over and over and over again. If you take a look, it's just lots and lots of duplicate movies in this thing. So there are thousands of lines in here of duplicate movies. You see there's the year and then the name of the movie. Let's say that we want to find out what the duplicate movies are. So step number one, the first attempt, and this code is not optimized, but it's a kind of a code that you will probably see somewhere in your lifetime. We have a main function, find duplicates movies, and the source is movies.txt, which is what we're using here. We're going to read in the movies using this read movies method, which we've defined up here. Let's take a look at that. We just use one of the with statements with open source as a file handle, return read.split line. So if you recall, split lines in this case, and I'm not sure if we covered that or not, but all it does is returns a list of movies, pretty much. That's what it does. So movies becomes a list over here. I have a duplicates, which is an empty list, and then I use a while loop. While the movies is not empty, let movie be equal to movies.pop. You may recall when we're going over lists that pop returns an element of the list, but also removes it from the list. So eventually movies will become empty and the while loop will stop. Then we call isDuplicate, passing to it our movie and the movies list. And if there is a duplicate, if it finds a duplicate, it appends it to the duplicates list, which is an empty list. Let's take a look at isDuplicate. It loops through the list, the current list. First, converts all the movies to lowercase so it can do a proper comparison. Remember, Python is case sensitive. So if a movie in movies is found in the movie list, well, if this movie in this list is equal to the movie that was passed, I'm going to return true. Otherwise, we'll return false. When we've gone through the entire list, we return the duplicates list. And I put a % find duplicates movie, how long it takes for it to run. Let's do a shift return, and let's see what we get. So this is executing right now, and it just finished. So we should get our list right here. And you can see that this program took a total time of 4 seconds and 31, hundredths of a second or whatever it is, 4.5 seconds to run the whole thing. And here's the list that was returned. Now, the profiler you can get, I didn't write this profiler. This is a copy and paste directly from Python. I put the list up here where you can go ahead and get it. You just have to import these libraries and then copy and paste the profile right here, and you pass to the function. Once you have this, then you can use profile as a decorator on any of your functions that you want, and it gives you, feedback. Let me go ahead and select this and do shift return so it's executed. I really wish that this would not skip lines, but it is. It's okay. So this is done at this point. Our second attempt right here, let's see where the problem might be. So you can see that I have the same exact code, but I put add profile on top of define duplicates, which is my main method. Let's do a shift enter here and wait for it to run. It's still busy. This is a previous attempt. I'm looking up here. Kernel is busy. Okay, so it's done. Let's take a look and see what we have. There it is, and I was looking at number 2 is what I wanted. Looking at this, we can see this number of calls and total times per call, etc. And where I can see the most calls is this is duplicate right here. You can see that I have it ran in 11.237 seconds because the profile was part of this. I can see that 7 seconds of that was find duplicate movies in here. And looking at it, I can see that this is duplicate is also taking a lot of time, about 4 seconds of that. Method lower of the string objects is being used. So let's take a look at option 3. I put some notes here. If we want to optimize, we need to look into is duplicate and in particular the string operation lower. Let's fix this by converting this string to lowercase when reading in the data. So I'm going to go in here to read movies, and I'm reading in my movies. Under is duplicate, I'm changing this line. I said, well, what I did was instead of having this complex is, if m lower is equal to that, etc. What I did was in the find duplicates, when I'm reading in the movies, I basically have a list comprehension movies is equal to movie.lower for movie in movies. So for each movie, as we loop through the list that we read, this is the, we read in this movies, we basically convert everything to lower. So we don't have to do that comparison every single time over here. So that's the only change we've made. We still have is duplicate, which is a problem, but let's go ahead and execute this third rewriting. And you can see this one finished much faster. It's already done. Looking down here, I can see that the total time, etc., dropped considerably. In other words, and I put a note over here, we have 10,000 movies, so we write the code below. Call lower 10,000 times instead of 27 million times. You may recall up here, it was in fact 27 million times that we were calling it. And we just did it for 10,000 by simply converting everything to lowercase as we read in the movies. So this time it ran much faster, and this is the third iteration. We went from 4.5 seconds down to 0.716 seconds by making that change. Huge improvement. Number 4, can we improve this further? Let's just check to see if the element is in the array. Remove is duplicate entirely. So I don't need to have is duplicate. I can just go and use the ability that lists have for checking something. So here I'm reading in my movies as you can see as before. In the while loop, instead of calling is duplicate, I simply say if movie is in movies. Once I've popped it, then append it. I've already popped it, so it's been removed. That movie has been removed. If it still exists in the list, then there's a duplicate in there, so we're going to add it to the duplicate and return the duplicates. Let's do a shift enter here, and this is going to run very quickly. We made another improvement. We went from 0.716 seconds by removing is duplicate to 0.31 seconds. So that's another huge improvement. So this was step number 4. Going further, let's take a look at this zip function, what zip is. It returns a so-called zip object. This is not what you think if you're familiar with zip files, zip folders, where you compress and put a bunch of things together. It's not that. It's taking two tuples or lists, structures like that, and you can say zip A and B, and it takes the first element from here, the second element from there, and basically ties them together. You can see that if the second element is longer, this gets left out at that point. So what I can do is I can improve this even further. We don't need to have this duplicate as we removed it before, but instead, let's go ahead and sort the array. So I have, or not the array, but the list. So I have movies, and I read it in, and here are all the movies that get converted to lower, which we did earlier. Now I'm going to call the sort method of a list. All identical movie titles will get to be next to each other once you have sorted them. I can use another list comprehension for checking the movies, and I put this movie 1 for movie 1, movie 2 in this zip that we create by taking in the elements of the movie, the first one and here the second one, and then we just move it down the list. So this becomes this first, second, second, third, fourth, etc. This backslash is so I could put the rest of it on this line. So if you didn't know how you could break a line, this is how you do it. And we have a conditional. Check to see if movie 1 is equal to movie 2. If they're duplicates, because they're sorted, they're right next to each other, this is going to return true, and that movie will be added to this list from the comprehension. So let's see how much improvement we got by doing it this way. Well, we brought it down from 0.03 seconds now to 0.024 seconds. Another huge improvement by just doing a little bit of logical change. This is how well I had come up with this solution. And on an occasion when I was teaching this to the US Navy, one of the students said, hey, I made another improvement. I used sets, which had never crossed my mind. And you may recall we went over sets, and sets do not keep duplicates by default. So if you put 3 things that are identical inside of a set, the set throws out 2 of them because that's how sets work. So we can have duplicates be a set and movies be a set, treat them as sets as opposed to lists, and then simply read in all these movies and add them to duplicates. And as you add them, basically the duplicates are thrown out and then return duplicates. So we have 0.024 seconds. Let's see how fast this one runs. And this brings it down to 0.013 seconds. Another huge improvement over this. It's half this is half the time of this one, pretty much close to that. Consider the fact that we started with 4.31 seconds or thereabouts, and we are now at 0.013 seconds. That's a 331-fold speed increase by doing some logical changes, by getting rid of some things that were totally unnecessary. And because we used the profiler in Python, we were able to pinpoint where some of the problems were, of course, to begin with, and then we used some logic, which the profiler had nothing to do with, but we used some logical approaches to make improvements. I hope this gives you an idea how to use Certainly to Profiler. I'm sure it does, but also how you can improve your code by trying to think differently, trying to think outside of the box, and never think that your solution is the final solution like I did. Once I brought it down to this point, I said, well, I don't think I can make it any better, but somebody else had even a better solution. Got a 100% speed increase, basically, half the time. I hope you enjoyed this video. It's one of my favorite things to teach is this particular lesson. If you're enjoying these, please share with loved ones and friends. Always thank you for being a great audience, and see you in the next one.